In the previous lesson, we were talking about HTTP methods, which deal with the semantics of sending a request to a REST API. In this lesson, we will talk about HTTP status codes, which help us communicate the status of the response. HTTP status codes fall under 5 large groups. Each of them has up to 100 codes, and they can range from 100 to 199. This is the 1XX group, and these are informational status codes. Then we have codes in the 200 range. These are successful status codes. Then we have codes in the 300 status range. These status codes deal with redirection of HTTP requests. Then we have codes in the 400 range, which represent client errors. And finally, we have codes in the 500 range, which represent server errors. So let's introduce some of the most popular HTTP status codes in each of the groups, starting from the status codes in the 100 range, which are informational status codes. In here, I have to highlight that these status codes are not commonly used, and you shouldn't really concern yourself with these status codes, as they won't be too relevant for building a RESTful API. The 100 continuous status code is often used when we want to check if a server is available for handling a specific request. The idea is not sending a large request to the server if it wouldn't be able to respond in the first place. Then we have the 200 group, which represents successful status codes, and common status codes from this group are 200 OK, which may or may not contain a response body, 201 created, which should contain a location header pointing to a URI containing the newly created resource. Then we have 202 accepted. This is often used for asynchronous processing when we want to send a request to the server and execute some long-running operation. The server may respond with a 202 status code and give us an identifier, preferably inside of the location header, that we can use to poll for the status of the long-running operation. 204 no content means that the request was successfully processed, but there is nothing to return from the server, and the response should also contain an empty body. Then we have the redirection status codes in the 300 group. A typical example is 301 move permanently, when we want to access a resource at a given URI, but it is no longer available at the given URI, so the server can respond with a 301 moved permanently response. The 302 found redirect can be used when the URI has been temporarily changed, and we use 304 not modified when we want to implement support for e-tags and the if non-match header. Then we have a large group of status codes in the 400 range, which represent client errors, and probably the most popular one is 400 bad request. This means that we have sent an invalid request to the API, and the API responds with a bad request. There is also the 401 unauthorized status code, which is used when we aren't authenticated and we attempt to send a request to the API. Then we have 403 forbidden. This deals with authorization and permissions, and we use this status code when the given client isn't allowed to do the requested action. 404 not found is typically used when we request a resource and the API cannot find it. 409 conflict can be used for optimistic concurrency when we manage a version of a resource on the server and we attempt to modify the resource that has already been modified by some other concurrent request. In that case, we can reply with a 409 conflict response and tell the client that they should fetch the most up-to-date state of the resource. Then we have 415 unsupported media type. This is self-explanatory. We sent a request with a media type that the server doesn't recognize. 422 unprocessable content is an interesting status code, to say the least. This should be used when you send a request to the server that is syntactically correct, which means it doesn't fall under 400 bad request, but for some reason, let's say because of a business rule, you aren't able to process this request. So you can reply with 422 unprocessable content. Now, because this is a course about pragmatic REST APIs, I don't think it's particularly valuable to respond with a 422 response even when you encounter a business rule violation. The question you should ask yourself is, will the client handle this status code any differently if I were using 400 bad request? And if the answer is no, then you are just introducing unnecessary complexity on the server. We're going to discuss this more when we go into our implementation. And the last status code from this group that I wanted to mention is 429 too many requests. This is used when you encounter a rate limit. Lastly, we have status codes in the 500 range. These are server errors, and probably the most popular one and the one that makes you the least happy to see is 500 internal server error. This means that the request you sent is syntactically correct, the server tried to process it, but something went wrong and we don't know what, so we are replying with a 500 internal server error. So I think we can agree that there are a lot of status codes that you should know about. Then the next question is, when should we be using these status codes? I tried to explain the use case for each one as we were going through them, but let's actually take a look at a practical example. Let's say we are trying to get a resource with this given URI, and we're using the getHTTP method. So we are respecting the HTTP semantics. Then what are the status codes that the API can respond with when we send such a request? If this is a successful request, and we find the resource that we are looking for, the API will reply with a 200 OK response. If we are sending an if non-match header, we could get back a 304 not modified response without the response body, which would save us some network bandwidth. And if it has been modified, then the server will reply with the response body and a new E tag that we can use for subsequent requests. I'm going to talk about this more in the advanced concerns chapter. If the resource isn't found, we would reply with a 404 not found status code. And if we run into a rate limit, the server will respond with a 429 too many requests status code. Now let's say we are trying to create a resource. We use the post HTTP method. And what happens if the result was successful? It's perfectly valid to return a 200 OK response. The more semantically correct response would be 201 created with a location header, and we can also return 202 accepted for asynchronous request. If the client makes a mistake and provides an invalid request for any reason, we should reply with a 400 bad request, and the same status code is appropriate when we encounter a business rule violation. In case of a put request, we can follow the same principles. 200 OK is a perfectly valid response, but a more correct response would be 204 no content without any content in the response body. Then for invalid requests, we would send 400 bad request, 404 not found if the URI doesn't exist, and we can send 412 precondition failed if we want to use an if match header and we don't find a respective match on the server. This can be used for optimistic concurrency control, and I will talk more about this in the advanced concerns section. And then for the delete method, we can reply with a 200 OK, a 204 no content, a 404 not found if the URI doesn't exist. Now here we could have a discussion about what is the reason for getting back a 404 not found response. One reason might be because we specified an invalid URI and this resource never existed in our system, but another use case could be trying to request a resource that did exist but no longer exists on the server. So in this case, you can reply with 404 not found, but another status code that you can use is 410 gone. Now this would require you to keep track of deleted resources, which is something you may or may not want to do. My pragmatic decision is to simply use 404 not found whenever I cannot find a given resource by specifying the URI. And then we have the two security-related status codes, 401 unauthorized and 403 forbidden. I always found it weird that the first one is named unauthorized, but you should actually reply with this status code when you aren't authenticated, whereas authorization refers to something different. The way I see it is authentication simply states who you are and are you a valid user in this system. For this, we could use something like a JSON Web Token that we obtain from a login endpoint, and then we send the JSON Web Token in subsequent requests to authenticate with the API. 403 forbidden should actually be unauthorized when we look at what it actually means, because it deals with authorization. It means that the client is forbidden from accessing a given resource or performing a given operation because they don't have the required level of permissions. So this was a pretty broad discussion about HTTP status code, and I want to finish this by saying that yes, HTTP semantics are important, but so is common sense. And I think I explained this nicely with the examples of returning a 422 unprocessable content versus using a 400 bad request for the same type of error. In either case, the request is syntactically correct, the server knows how to accept it, but we aren't able to process the request because of some business rule violation, for example. I don't think that using quote-unquote exotic status codes like 422 unprocessable content or 410 gone adds a lot of value to your REST API, so you can keep it simple and use the standard set of status codes that are expected in a given situation. In the end, this is all about being pragmatic while trying to build a quality REST API. And because we want to provide a high quality and easy to use REST API to our clients, there are some best practices that you can apply when designing your REST APIs. And this is what we will cover in the next lesson.